All right, here we get to learn about the perimeter of composite figures. So you've definitely heard the word perimeter before. It means the border of a shape, the distance that goes around a shape. A composite figure is more than one simple shape put together. So a composite figure is made from a combination of many, or I'm going to just say multiple, simple shapes. So more than one simple shape put together. And when I say a simple shape, really just mean anything that you see on your formula sheet. So you're going to have this formula sheet for this entire unit for the rest of the year, and for the SOL, it has these exact shapes on it. So you can see that we have perimeter and we have area formulas for each of these. We're actually not going to rely on perimeter formulas so much for these, because when you put two shapes together, you're going to have parts of this perimeter that are not going to be a part of the overall perimeter. So when you just look at a rectangle, the perimeter is going around the outside. If you put a rectangle together with a triangle, two of those sides are going to come together, and then one side, or really two sides, are not going to be a part of the overall perimeter anymore. So we're not going to rely on the perimeter formulas so much. We are going to use the area formulas a lot. But these are the simple shapes that I'm talking about. Really, rectangle, square, triangle, circles, trapezoids. Those are simple shapes. It's just one shape. Composite figures are two of those shapes put together. For perimeter, we are going to use this Pythagorean theorem to find the missing side in a right triangle at times. So, words that we have to look out for that mean perimeter are border, the distance around, and then the units we want to look out for are something like meters, inches, feet, miles. These are abbreviations. That means meters, that's inches, that's feet, miles. Those are measures of distance. That's what we're talking about when we're talking about perimeter, the distance that goes around a shape. So to find the perimeter of a composite figure, we are first going to highlight the outside of a shape. Outside of the figure. Figure is just a geometry word for a shape. It's a closed shape. Actually, it doesn't even have to be a closed shape. It's just a general word for a picture. Find the missing sides, and then we add them all up. We only add up the outside lengths together. There's going to be parts on the inside that we might need to use to find the missing sides, but we're not going to use those for the border of the shape. So when I say highlight, I really just mean go around the outside of the shape. So that, and that, those are part of the perimeter. We're going to add up all those sides. You can see that we're missing some of these. We're missing this one, and we're missing this side at the bottom. All right, so to find those, if this whole thing is 10, that side is 10, and I'm looking for this side that's directly across and it's lined up with that 10. It's only part of that 10 though. The rest of that 10 is coming from this section. This and this together combine to make that 10. So 6 plus something has to give us 10. We're just going to subtract those two and find out that that is 4. Similar logic here for this bottom side. That side is this part up to here, and this is the rest of it. Those two pieces put together, this 3, this 6 put together, that makes 9. That green side at the bottom has to be 9 because it's this section and this section put together to make that whole side. Now we have all the missing sides. Make sure you're not going to add up these, the 3 and 6 combined to make the 9. That 6 is a part of this 10. We're really just going around the outside. 10 plus 3 plus 6 plus 6 plus 4 plus 9 is 36. And we're going to put units on this. We're talking about meters here, so it's 36 meters overall. All right, we have another few rectangles that are put together. So you can see we don't really want to use the formula for perimeter of a rectangle. If we look at this rectangle, that rectangle, this part is not really a part of the perimeter. It would be a part of this perimeter of this small rectangle within the bigger shape, but it's not really a part of the overall perimeter. So I'm going to erase that and highlight just the outside of this shape. You can see I'm missing that side, that one too. I have that one, I have that one, I'm missing this one. I have the rest of these. All right, so let's find the easiest one first. This one, if that's 4, that's also going to be 4. If this is 8, across from that has to also be 8. Now we're just missing the side at the bottom. Same logic as what we're using here. This part is 4. The middle section is also 4. That takes us up to there. This third part from there to there is also 4. So it's 4 plus 4 plus 4, which is 12. Now we have all the missing sides. We can add them all up. So we add those up together, and we get 48 centimeters. All right, here we can see that we have a triangle that's attached to, I'm looking at a rectangle and another rectangle. You could also see this as a trapezoid, but really I'm focused on this slanted side right now. Anytime you see a missing slanted side, that means we're going to have to use Pythagorean theorem. It's a missing side in a right triangle. So I'm just focused on this triangle right now to find that missing side. I'm going to highlight the rest of the shape just so I know what else I need to find. I have most sides. I'm really missing this section. I know this whole thing is 8. I'm going to actually find this first before I find the slanted part of that triangle. Before I find the hypotenuse of that triangle, I'm going to find this little section. So I notice that it's across from this 8. So it's a section of that 8. It's part of that 8. Oops, sorry, I jumped to the answer. Sorry. I notice that it's part of that 8. I see that this is the rest of that 8. So that part's 5. From there to there, there to there, that part's 5. The rest of that has to be 3. That has to be equal to this part. All right, now I can find this part in that right triangle. So to find a missing side of a right triangle, I'm going to need 2 of these sides. So I need these 2 sides. I'm just going to redraw that triangle just so I can see it clearly. My right angle's there. I'm trying to find the hypotenuse. I don't know the C yet, but I actually do know the A and the B. I know that 3, I'm going to call that my A. And I do know the B, even though it's not immediately labeled here. I see 4 is this part. So this up to there is 4. And the whole way across is 12. So if the whole way across is 12, that part of it's 4. 12 minus 4 would tell me that this part's 8. So is that. There to there is 8. So there to there has to be 8 also. So now we have our A, we have our B. Now we can find C. We're going to do 3 squared plus 8 squared equals C squared. That's 9. That's 64. So that's 73. So C squared is 73. So C is the square root of 73, or 8.54. I'm going to just round that to the hundredths place. So this side is 8.54. I'm going to clean up this picture just so I don't miscount something. I just want to do the border. So anything that's on the outside. This 4 is on the inside of the shape, but it's labeling part of the outside. I could just as well write it there, if that makes it simpler. But it really is just labeling that part of the shape. You just go around the outside, adding up all of those lengths, and we end up getting 43.54 centimeters. All right, here we can see we have another example with some triangles. I have a right triangle here. There's my right angle. I want to find the side that's across from that right angle, so I'm going to have to find another C. Same kind of things happening down here. I have a right angle in that corner. Across from that, that's going to be C. So I'm going to find C in this triangle, C in that triangle, and then I have one more missing side that I have to find, that side. So I'm going to highlight just to make sure I get all of them. I'm going to find that one first just because I think that's the easiest one. From there to there is 8. That takes us from there to there. The rest of that is 2, so it's 8 and 2 together, so that's 10. All right, then in that right triangle, I'm just going to redraw this. This side's 2, that side's 2. My C is the one that's missing, so I have A squared plus B squared equals C squared. So 4 plus 4 equals c squared, so c squared equals 8. So c is the square root of 8, or 2.828. I'm going to round that to 2.83. So this side is 2.83. I'm going to do the exact same thing with this right triangle. So I have my right angle down here. 4 is the bottom side. 3 is the height of that triangle. That's my A and B. I'm looking for C. It's the one that's across from the right angle. So I know it's going to be bigger than 3 or 4. So C squared is 25. So C is the square root of 25, or just 5. That's all my sides. Don't include this 2. Remember, it's just the outside of this shape. I'm actually going to erase this part too, just to make it clear that I'm not highlighting that. It's just the border of the shape going around the outside. Adding up 5, 4, 8, this 2.83, this 2, 3, and 10 gives me 34.83 feet. All right, on examples 5 and 6, you can see that on both of these, we have part of a circle. We have half of a circle. So, when you're not sure how to do something, first step should be go to the formula sheet. If you don't know how to find the missing side of a right triangle, it's right there. It labels everything for you. It tells you A and B are connected at the right angle. Across from that, that's C. That tells you how to set up Pythagorean theorem. If you don't know how to find the perimeter of a circle, it's not directly labeled on here as perimeter. It's called circumference, but that is the perimeter of a circle. Circumference is the distance that goes around a full circle. You can use either of these two. This one is using the radius. It's 2 times pi times the radius. This one's using diameter. That's it's pi times diameter. And you can see that would give us the same thing. The radius goes halfway across. Diameter goes the full way across. So it's just saying 2 times the radius, which is the exact same thing as diameter. These are the exact same equation. Whichever one you're given, that's the one I would use. If you're given the radius, use the top one. If you're given the diameter, use the bottom one. That finds us the distance around a circle. I believe the SOL uses 3.14 as an approximation for pi. So instead of using the pi key, I'm going to use 3.14 each time and round to the hundredths place. If you're given a practice problem and you use the pi key, I don't think I would ever really mark that wrong or say that you have to go back to that question. But just keep in mind, on our test, we're going to use 3.14, and the SOL is going to use 3.14 for an approximation of pi. All right, so let's highlight the entire shape. 6, 5, 3. I'm missing this side, and I'm missing that half circle. The 4 is labeling this dashed line. I'm going to redraw that circle with the dashed line cutting across, just so I'm clear on what that 4 is really labeling. I'm going to label this side real quick. If that's across from this side in a rectangle, those have to be the same, so that's got to be 6 also. All right, now for the half circle. I'm trying to find this part of the circle. Remember, for circumference, I could use pi times diameter, or 2 times pi times the radius. Either of those work. Really just depends on what I'm given. So here, I'm given the entire way across that circle. That cuts the entire way across the circle. That is the diameter. The diameter of this circle is 4. I'm going to use this top one, just because that's what I'm given. So the circumference of the circle would be pi times the diameter, pi times 4, or 12.56. That's the full distance around a circle that looks like that. A circle with a diameter of 4, the circumference of that circle is 12.56. That's not really what I have here. I only have part of that circle. I have half of it, so I'm going to divide that by 2 and find out that this half circle, the distance around that is 6.28. Now I can add up all my sides. Remember, the 4 is the diameter of the circle. That's not a part of the border of that shape. Just the stuff that I highlighted in red there. That's what I'm going to add up and find out that that is 26.28 feet going all the way around. last one, I'm going to highlight the outside of the shape. So I have some sides that I have to find here. I got to find the bottom of this rectangle. This one. I have to find the missing side in this right triangle. And I have to find the top part of this circle, the top half of that circle. All right, so first off, I'm going to just label what this 3 is really talking about. The 3 is going halfway across that circle. That's the radius of the circle. I'm going to redraw that with the 3 labeled inside of the circle. 3 is the radius of that circle. If 3 is the radius, then 6 is the entire distance across. If that's 3, that's also 3. That means this length, going all the way across that rectangle, has to be 6. All right, as long as I'm talking about the circle, let's use that to find the top half of this circle. So I'm going to use 2 pi r here. I'm using this one because I'm given the radius. So 2 times pi times 3. That's 18.84. That's the full circumference of a circle. That's that size. I only have the top half of that, so I'm going to divide this by 2 and find out that that point is, I think that's wrong actually. That's 0.42, sorry. 9.42. That's the top half of the circle. This is the full circle. I only have the top half, so I divide it by 2. All right, now for this missing side in that right triangle. Here's my right triangle. I'm missing the side that's across from the right angle. I have the base side. I have the height. If this is 4, that's also 4. I'm looking for C. I'm looking for the one that's across from the right angle. So I'm going to do a squared plus b squared. That's going to equal c squared. That's 16 plus 16, or 32. So c squared is 32. So c is the square root of 32, or 5.66. I'm just rounding that to the hundredths place. All right, now I have all my sides. Remember, the 3 is the radius. That's not a part of the border of the shape. It's cutting right through the middle. So you're just adding up the ones that I circled there. We're going to get 29.08 meters as our perimeter. All right, you're going to spend some time working on this. You try on your own. If you need to go back to the video, rewatch the video. These shapes are exactly like the shapes that you're seeing here. Use that to help you. Also, use the formula sheet. If you get stuck, this formula sheet describes everything in the shapes that you're going to see and how to use them.